graphical representation of data. From the statistical point of view, graphical presentation of data is more appropriate and accurate than the diagrammatic presentation of data. Graphical presentation of statistical data gives a pictorial effect to what would otherwise be just a mass of figures. The word graph could well be associated with the word graphic, which means vivid or spiraling to life. This is exactly the kind of function which the graphic should perform for the statistical table from which it is drawn. If a huge mass of data are depicted in the language of lines and curves, they become easy to understand and grasp. Graphs are used for representing frequency distributions. Rules for the construction of a graph. The following are the main rules to be remembered while constructing a graph. A graph should be as simple as possible. It should be neat and clean. It should be appealing to the eyes. Every graph must have a clear, comprehensive title which should be written to convey the main idea that the graph intends to portray. The graph must suit to the size of the paper. As far as the scale of the graph is concerned, the independent variables should always be measured on the x-axis and the dependent variables along the y-axis. The scale of y-axis should always begin from 0 as its origin. Footnotes should be given at the bottom to illustrate the main points about the graph. If more than one line is plotted on the same graph, it is necessary to distinguish those by different patterns. If the scale caption for the x-axis should be placed under the center of the horizontal axis, whereas for the y-axis it is placed either at the top or the middle of the y-axis. An index should be given to show the scale and the meaning of different curves. Every graph should be given with a table to ensure that the data has been presented accurately. The test of a good graph depends on the ease at which the observer can interpret it. Graphs are always attractive and impressive and also easy to understand, and so as to make valid conclusions from the data. In graph, all the features of data become visible at a glance, which may help in studying the tendencies and functions of the data accurately. Graphical methods enable statisticians to present quantitative data in a simple, clear, and effective manner. Comparisons can be made very easily with two or more phenomena in the help of a graph. The frequency distribution can be represented as a histogram, frequency polygon, frequency curve, or cumulative frequency curve called orgave. A histogram. Histogram is the most important method for displaying the frequency distribution. Histogram is a set of vertical bars whose area is proportional to the frequencies represented in the table. It's a popular and commonly used device for graphing continuous frequency distributions, no matter whether the variable under study is continuate or discrete. It consists of erecting a series of adjacent vertical rectangles on the sections of the horizontal axis, that is x-axis, with basis sections equal to the width of the corresponding class interval and height proportional to the corresponding frequency of each class, so that the area of the rectangle is equal to the frequency of the corresponding class intervals. Difference between histogram and a bar diagram. One has to consider the following differences between a histogram and the bar diagram. A histogram is a two-dimensional diagram where both the width and the length are important, whereas bar diagram is a one-dimensional diagram in which only length matters. In a histogram, the bars are adjacent to each other, whereas in a bar diagram, proper spacing is given between bars. In a histogram, the class frequencies are represented by the area of the rectangles, while in a bar diagram, these are represented by the height of the corresponding bar. A frequency polygon. A frequency polygon is a curve representing the frequency distribution. It is an effective graph for comparing two or more frequency distribution. A frequency polygon is constructed from a histogram by joining the midpoints of the top of various rectangles by straight lines up to the baseline. The total area of the frequency polygon is equal to the total area of all the rectangles put together. It provides a continuous curve showing the gradient of rise and fall of the data. Generally, it is used only when class intervals have a common width. Frequency polygon is drawn on the presumption that frequencies in a class interval are evenly distributed throughout the class. A frequency polygon can be turned into a histogram. A frequency curve. A frequency curve is a smooth, free hand-drawn curve through the various points of the frequency polygon in such a manner that the area under the frequency curve is approximately the same as that under the frequency polygon. The histogram and frequency polygon are based upon a sample which consists of a few items. As the number of items in the sample is increased, the distribution becomes smooth because accidental discontinuities are eliminated. The smoothing of the histogram and the frequency polygon results in a continuous curve which is named a frequency curve. The total area under the curve should represent the total frequency of the whole distribution. A cumulative frequency curve or ORGIV. A graphical representation is also known as a cumulative frequency polygon. The cumulative frequency polygon is drawn by joining straight lines of the cumulative frequencies plotted against the corresponding class boundaries. ORGIVs are especially useful for comparing different frequency distributions with equal as well as varying class intervals. There is less overlapping in ORGIVs when drawn on the same graph as when compared to frequency curves. A stem and leaf plot. A stem and leaf plot is like a histogram. They are both tools to help you visualize data. Stem plots show a little more information than a histogram and have been a common tool for displaying data since the 1970s. They are typically used when there is a medium amount of quantitative variables to analyze. Stem plots of more than 50 observations are unusual. The name stem plot comes because there is one stem, and when the largest place value digits to the left and one leaf which is placed on the right. Stem and leaf plots are useful in some cases because you can see where the bulk of the scores lies. Bar graphs can also show this information, but the advantage of the stem and leaf plot is that you can see all of the scores. These types of charts gives you a quick overview of a distribution, and you can also see the shape of the distribution. They are also useful to highlight the mode in the data. Disadvantage: they are only useful for small sets of data, roughly from 15 to 150. More than 50 is unusual. Dot plots are usually more useful for smaller data sets, and for a larger data set, a box plot or a histogram can be used. A box plot. In descriptive statistics, a box plot is a method for graphically depicting groups of numerical data through their quartiles. Box plot may also have lines extending from the boxes called whiskers. They indicate the variability outside the upper and lower quartiles. So they may also be called box and whisker plots or box and whisker diagrams. Outliers may be plotted as individual points. The box plots are non-parametric, that is, they display variation in samples of a statistical population without making any assumption of the underlying statistical distribution. The spacings between the different parts of the box indicate the degree of dispersion or spread and the skewness in the data. In addition to the points themselves, they allow one to visualize and estimate various estimators, including interquartile range, mid-range, mid-range, and tri-mean. Box plots can be either horizontally or vertically represented. They receive their name from the box found in the middle. Scatter diagram or a scatter plot. It's a graph pairs of numerical data with one variable on each axis to look for a relationship between them. If the variables are correlated, the points will fall along a line or a curve. The better the correlation, the tighter the points will hug the line. This is an analysis tool. When to use a scatter diagram? When you have paired numerical data, when your dependent variable may have multiple values for each of your independent variable, when trying to determine whether the two variables are related, like when you're trying to identify the potential or root cause of a problem, when you're testing for autocorrelation.